So at this point, you've already recorded your moving object flying through the air, and it's time to try to get some data out of the video that you made of it. We're going to use the program Tracker, which is a project of the Open Source Physics Project and Doug Brown at Cabrillo College. It's a fantastic program, and it's going to get us very high quality data for the split second that you actually had your object in the air. So you've already sent me the video, and I've put it on one of our classroom computers. They're all running some version of Debian or Ubuntu Linux with the Mate desktop, which is pretty easy to use. So the point of this video is going to be to kind of show you exactly how to analyze your video. I have a set of step-by-step pictures if that's more helpful as well. But hopefully this will get your video analyzed, get your data off the classroom computer and onto your own device. So the first thing you do is you go to the Applications menu, which is in the upper left corner. And the program we want is under Education, and it's Tracker. It'll take just a second to load. So to find your file, go to Video, Import. And the place you'll find it, whatever directory it brings you to, if you click on the little house, you'll go to the Home folder. It'll be under Documents, and it'll be your period. And you just look for the video that corresponds to yours. The longer the video, the longer it will take to load. And this is what you'll be presented with. So your video may have any orientation. It depends how your camera was set up and how your camera reported the orientation. If you're not straight up and down, you go to Video, and you go to Filters, and you just look for Rotate. And you pick whichever one's appropriate for you. And then close. So now the video is ready to go. First thing you want to do is you want to find the place where the meter stick is visible, because the meter stick is how we're going to scale. Time data is going to come from the video itself, but the computer has no idea how far away our motion is, so you need to set the scale. So I've got the meter stick visible there. I'm going to go up to this little button here. I'm going to go to New Calibration Stick. And then you just basically put one end of this blue line at one end of the stick. I'm trying to use the left edge. And one end at the other. This is a source of error, of course. You just do the best you can. And then you click on the numbers and you change it to 1. And since it's 1 meter, that means all our units now will be in meters and seconds. So that's big thing number 1. Big thing number 2, there's no guarantee your camera was straight, so you need to find something in the video that's horizontal, either the lockers or the ceiling or something. And you click on the set of axes here, and the X and Y axis show up. And you just grab the origin and you move it to something you're fairly confident is a horizontal line. And then you can click somewhere out on the x-axis and drag, and you can kind of spin it up and down until you get to the right place. Okay. So now you should find in the video where the motion actually is. And it's probably towards the end. I'm telling everybody in the video how to use the video, so that's why I keep talking. When you get close to where you are, you can step using these controls. And you want to find the one where it's no longer touching your hand. I think that's the one where it's no longer touching my hand. So we'll drag our axes over to where the bird started. Put it right in the middle. And now we can hide the calibration stick by clicking on its button, and we can hide the axes by clicking on theirs. We're going to call this time 0, the original time of our motion. So you go down to this number here, which is the frame number, and you click on it, and you click Set Time to 0. And now we're pretty much ready to go. You just need to tell the computer to look for a object. And you do that by going to Create, Point Mass. And it goes back to the beginning of the video. So you scroll back till you get to your time 0. Notice the time on the bottom now is in seconds instead of frame number. So I'm getting close. Right on the button. Again, if you weren't on the button, you can click through with these guys. Alright, so as it's saying right here, it says shift click to mark. So I'm holding down the shift key, and as I do, the cursor is changing to some crosshairs. You just go right in the middle of the bird. And it auto advances. Notice the bird starts out really blurry, and that's because it's moving really fast in the 0.033 seconds there is to take each picture. So that's pretty fast, but something kind of amazing happens. As the bird goes up, it becomes clearer, which implies it's slowing down. And the reason for that is the force of gravity is getting rid of that initial velocity. And eventually, at the very top, actually brings it to rest for an instant. That's why it's so super clear. Now it's going to continue to pull down, so it's going to speed up in the downward direction. But I always have people remember that the velocity at the top, at the maximum height, is 0 because the object's not going up anymore, so it doesn't have a positive velocity. And it's not coming down yet, so it doesn't have a negative velocity. And I think this exercise really shows that clearly. So we're getting blurry, moving faster and faster. And you just keep clicking until you can't see it anymore. Some of you may have less data because, especially if you had a bird that was the same color as your shirt or something, it's a hard time seeing it. That's the last one for me. So now I let up, and it shows the last few points. Now, I've got this nice sort of linear pattern over here. And that pattern actually has some meaning. But if you look, it says time, comma, x. And x is our horizontal back and forth distance. So the fact that that's somewhat linear is very interesting. And it's something we'll get back to in a later lab. But we were interested in y, our up-down distance. We're not as interested in x. To see the y, you go to plot, and you go to 2. And you can see the y information down here. And it's a beautiful looking parabola. And it's a parabola that's going to have a very important bit of information about the force of gravity. So I'd like to study it. There's not much more we can do on the classroom computers since they've got no network. I'd like you to analyze the data on your own devices. So I want to walk you through the easiest way I found of getting the data off. If you go over to this table and you go up, you just click on the first cell, hold down the shift key, and then just highlight everybody. Once you got that done, go to Edit, Copy Selected Cells Full Precision, and then you go to the Applications menu, and under Accessories, choose Pluma Text Editor. So then you paste. And then as you save it, I want you to save it in 2 places. One problem with shuttling things around with flash drives is if somebody unplugs flash drive before it's stopped, it can corrupt the drive. So you don't want to lose all your data. So I think having a copy on the classroom computer is a good thing too. So save it under Documents, choose your period, and give it a name. Key thing is .csv at the end. CSV stands for comma separated value, and any spreadsheet program will know that this is data and to open it in a spreadsheet. So go ahead and save it in that folder. It turned green because it actually put that into spreadsheet format. I know it looks weird, but don't worry about it. If you could save it a second time, so go back to Save As. And this is where you're going to choose that flash drive, which is off to the side. And just save it there too. So you're done. You can close everything out because we're not going to need it anymore. Don't have to save. Then the key thing and the very important last step is go over to the flash drive, right click, and choose Eject. And don't pull it out till you see it unmount. Same goes with your Chromebook. Do not pull it out of the Chromebook until you see it unmount, because we'll have to reformat the drive, and that's why we made the second copy. So we'll pick this up and we'll analyze the data on our other computer.